So for this bell work, we'll find the approximate rate of change from -1 to 3. So just like we saw last time, these are both x values. You got a first x value that's -1. You got a second x value that's +3, which means we need to find these x values on this number line right here. So I'd look and find it's not showing this value, but -1 is this line right there. And then I got to find where it connects with the graph. So I would follow this up, and yeah, that's not an exact point, so I'm going to have to estimate that value. I'm going to put it halfway through. So this is going to be at -1, and then positive 0.5. You're welcome to use the fraction if you'd like, but we're going to put it into the slope formula anyways. So it's a rate of change, which is slope. And now that we have a value, we can put it into the formula. So in the formula, remember, it's always a fraction line with subtraction. And in addition to that, x's always go on the bottom, and then y's go on the top. So for my first ordered pair, the x value is -1, so it goes on the bottom. And the y value is 0.5, so I'm going to put that on the top. But we need the second ordered pair, but it says the x value is 3, so I got to find where 3 is on the graph for my x. So there's 0, 1, 2, and 3 for my x. It's right there. Again, it's not showing the number 3, so you can write it in if you'd like, but you don't have to. And then I'm going to follow this line up until I get to the graph. So I'm going to follow this up, and there's my point right there. And from what I can tell, that appears to be the point. The x value is automatically 3 because that's what we were looking for, but the corresponding y value is 8. So with the x value that's 3, it has to go on the bottom of my slope formula. And with the y value being 8, it has to go into the numerator of the formula. So I'm ready to put this into the calculator. And when I do, I'm going to put parentheses around the numerators and denominators. Remember, the fraction line just represents division right there. So I'm going to type this in. Open parentheses, 0.5 minus 8, close parentheses, divide. Open parentheses, -1 minus 3, close parentheses, enter. And I get this decimal. 1.875. Now, since we did approximate the green ordered pair, the y value for the green ordered pair, you may not have gotten this exact value, but you should get something pretty close to it. Okay, so pretty much if you're within, I'd say probably even a tenth on this one, you should be good. So something like 1.9 would work. Probably something as low as 1.7 would work as well. Something like that, okay? Here's our objective for the day. I can determine if a graph is linear or exponential, positive or negative, increasing or decreasing, and where the asymptote is. And then we got another objective there. I can find x-intercepts and y-intercepts and rates of change for graphs. Of course, we've done rates of change already, so that's not a new objective for us, but it's still part of today's objective. So take a minute, copy that down, and we'll get started. But just so we understand, pretty much all this stuff right here, not the rate of change. I'm not talking about the rate of change right now, but all this stuff right here. We got linear, exponential, positive or negative, increasing or decreasing, and where the asymptote is. Same with the x and y intercepts on this stuff. All these objectives right here are just asking, are you going to pay attention today? That's it. Now, because if you can't, this is just, can you look at the graph and find these things? Now, it's one thing to be like, I don't know what the crap an x-intercept is. All right, well, that's problematic too. But if you're paying attention and don't know what it is, okay, that's different. But if you're not going to pay attention at all, don't expect this stuff to work for you, okay? Because positive or negative, just look at the graph. Can you see the graph? That's all we're really asking. And if you can't see the graph, then what the crap, all right? Same with linear exponential. We've done that one before. Increasing or decreasing, again, well, we haven't done that one before, but asymptotes we have done. Okay, so can you see where the asymptote is? And the asymptotes, they're not going to throw any weird, freaky stuff at us. So it'll usually be pretty obvious where it should be, all right? So keep that in mind, and then x and y intercepts too. So today, really, we're just going through this lesson like, are you going to pay attention today? Because if at the end of the lesson you're like, I don't know how to do this stuff, then we know that you're okay not paying attention. Linear or exponential graphs, because these are graphs are visual, you're looking at the graph. That's all you're going to do. And right here, if it's linear, you're just looking at the graph and determining if it is a straight line. So I don't know how to define straight very well. I'm going to say that it has no curvature at all. It doesn't deviate. It is straight. It is constantly changing at the same rate. I don't know. Something like that. Can you look and see that it's a straight line? Because if it's not, then it's likely to be curved. And if that's the case, then it's exponential. You get two choices on this. Now, because people still don't pay attention, even though I've been explaining this, on the assignment, what they're going to do, they're going to say linear, exponential, or neither. And then I know if you guess neither, because that's all you're doing is guessing, now I know how much you were paying attention today. So no calculating at all here. We're not asking you to calculate. Just look. Can you see the graph? So this one, determine if the graph is linear or exponential. Now, if you can't see that, you can look at your paper, because I know I'm projecting it, right? And sometimes this line gets pretty small or thin.
Curve.
Yeah, I can see it's curved. I hope that you can see it's curved. Since it's curved, automatically, it's exponential. So, did we have to calculate anything right here? No, we didn't. You just had to look. Can you see that it's curved? I can. I hope that you can, because that makes it exponential. All right then, positive, negative, or both. So graph is positive if it is completely above the x-axis. Okay, so all of these are going to refer to the x-axis. All right, so you're just looking, and you're not calculating anything. You're just looking at the graph. And if the graph is completely above the x-axis, then it is positive. Now, just in case you don't remember, the x-axis is the horizontal number line. Okay, so you're looking at the horizontal number line, just like we did on the bellword, and finding your x values, right? But you're looking at the graph. Is it always above the x-axis? Because if it is, it's considered positive, because all of its y values would be positive. If by chance the graph is completely below the x-axis, then we would consider it negative. All right, so again, you're just looking at the x-axis. Is it below it? Is it beneath it? Because if it is, automatically negative. The last one here, maybe it crosses over right here. Maybe it crosses over the x-axis. Well, if it does, then it's considered both positive and negative, because some of I know we're talking about the x values here, but in the end, it's all about the y values, right? So both down here, it's just saying maybe some of the y values are negative, but maybe some of them are positive. And you can see that on a graph because it will cross over the x-axis. So here's the same example, right? And this line, I can say I can follow it up here, and it's getting really close to the x-axis right here. Now that's going to lead us into an asymptote, which we've talked about already. This red line is getting very, very, very close to the x-axis, but it will never cross it because
Negative.
the x-axis is a asymptote. Because it's completely beneath the x-axis, so this one would be considered negative. I'm just going to stress this again because I just want you to understand. We're not asking you to calculate anything. I know math sucks, right? Like we don't want to calculate stuff really ever. But we're not asking you to do that right now. Just can you look at this and see that it's below the x-axis? Okay, this one is, so it's negative. Just keep in mind, remember, if it had crossed over, maybe it crosses over here somewhere, then it's both. And if it was just completely above it somewhere over here, then it would be considered just positive. Okay, so increasing. A graph is increasing. Now, again, there's just a visual check, no calculations, right? Is it going up from left to right? So in the past, we've seen this with slopes. That just means it has a positive slope, something like this. It's sloped upwards. Now, since it goes from left to right, and since it's recently snowed outside, I'd say it's like you're going up a hill. You know, you're taking your sled up a hill. So you'd have to climb the hill. You'd have to go up it. right? But it's always from left to right. Now it'll be decreasing if it goes down. This time it's going down, but again from left to right. So these are going to be sloped in a downward fashion. And back when we went over this in 8th grade, we would say it has a negative slope. Negative slope means that you'd be at the top of the hill, and then you take your sled and slide down it. Okay? And yeah, sometimes they're not always straight lines like these ones. Sometimes they're curved, you know. I think the curved one would probably be more fun, but maybe more dangerous, whatever. And same with the ones that are increasing. Sometimes they're, you know, that's kind of a crappy curve, but it still works. So this line right here, again, always start on the left. So I'm going to start down here, and I would have to go up this hill, right? I have to climb it. Since I'm climbing it, this one would be increasing. Okay, and again, that's because from left to right, it's going up, up, up. Now, you can see it starts to flatten out here at the end of the curve because of the asymptote. It doesn't matter. It technically is still going up, even if it's very, very, very small over here. So did we have to calculate anything on this? No, we didn't. We just had to look, see if it's going up from left to right, not from right to left. Is it going down from left to right? Okay, but this one's going up. An asymptote is a value that a line gets really, really close to, but it will never actually cross or touch, just like we saw on this graph. So we've kind of covered it already, but we'll still look at it. So for the graphs we're looking at again, the line you're going to see is going to begin to level out, unless it's a straight line. If it's linear, that's going to be different. Okay, so you'll see the curvature, you know, something like this, maybe even something like this. Now, like I was saying, is they're not going to say, well, you know what, actually over here this line's going to dog leg back down. We're not going to do any garbage like that. So these lines are all exponential, so they should have this, some form like this, right? I mean, some of them are kind of like this one, or some of them are maybe like this, if they're exponential. So again, there's no tricky business going on. Just look and see. You can see it get really close to one of the lines. But all of these lines are going to be horizontal, and that's important for us to remember too, because horizontal lines, this goes back to Unit 2, but they're going to take on the form y equals. So you just look at, since it's y equals, it's horizontal line, you look and see where does the line get really close to the y value. So you may have to trace it back to the y number line, the y-axis, to figure out what this number is, but it's just y equals some number. This is not y equals mx plus b, because there's no slope on the line, because it's directly horizontal, it's flat. That's where the asymptote will be. So on the ones that I've drawn, even though they're, you know, kind of garbage-like, you'd have maybe an asymptote like this. But again, you can see this line, it gets really, really close over here. Okay, or maybe this one. See? So once again, you kind of see how it creates a wedge right there? That's because it's getting really close to that. None of our asymptotes right now will be vertical, so just keep that in mind. Don't worry about x equals stuff. And then these other ones, you know, I'm just kind of drawing what they should approximately be like, something like that. I don't know what's going on with the microphone. Okay, so asymptotes. So this one, I would say, again, you see how it's creating a wedge right here? So there's my wedge, right? It's getting really close. It's flattening out. It's becoming very flat right here. So that means that I should have an asymptote along this line. I'm doing this by hand, so that's pretty flat. I don't know, I've done much worse. So there is an asymptote. It's starting to level out. This means that I should have an equation, y equals some value, and the value that I see on the y-axis, that's where the y value is 0, because I can see -1. Immediately above it would be +1, but that right there is showing that the y value is 0, which is the x-axis. Is it always going to be the x-axis? It is not. So don't expect it always to be just y equals 0. You got to look and see, right? Just like we did on this one. Did it get really close to a value? Yeah, it's getting really close to where the y value is 0. Now this one's negative because it's below the graph. Yeah, sometimes they'll be above the graph and they'll get close to the x-axis as well. But again, no calculating on this one. Can you look and see where the value is? That's it. So x and y intercepts. The x-intercept is where the line crosses the x-axis. That's the horizontal number line. And then the y-intercept is where the line crosses the y-axis. We'll need to keep in mind, on the assignment actually for the x-axis, it may not ask for the ordered pair because we may have to estimate some of those. But it will ask for the ordered pair on the y-axis. If that happens, so what's going to happen on the assignment, you'll see parentheses like this for an ordered pair. But then it's going to have a box here with a comma and then a box here. That means it's asking for the x and y value. And again, this is one of those things where we know if you're paying attention or not, because the y-axis, the y-intercept rather, always has an x value that's 0. So right here, when I put 0 in, if you ever put anything but 0 on this, we know you either weren't paying attention. Maybe you got these mixed up. That happens too. But if I ever see something other than 0 here in my x value for a y-intercept, then I know that you probably weren't paying attention, okay? Now the x-intercept, if it asked for a ordered pair, the corresponding y value then would always be 0. Okay? Again, I don't think it's going to ask for this, but we're just looking for an x value, which tells you that you should be looking at the x-axis specifically on this, all right? Just like the y-intercept, again, you're looking for a y value, which means you should be looking at the y-axis, the vertical number line. So can we find a x-intercept on this one? Now it's just asking for the x value, just like I was saying it probably will on the assignment. So I don't actually have to look and see or make an ordered pair on this one. But I do have to see where it crosses. Now you'll say it should cross here, maybe right here at 0, right? But again, it's not actually crossing the x-axis on this one. So this one actually, there's just none. And that happens because there was actually an asymptote at the x-axis. What is the y-intercept on this one? So the y-intercept should go through the y-axis as my vertical number line here. And again, can you see what that value is? So y number line, can you see it? Do you see it? I hope you do, because I see it. Boom, right there. In fact, it's showing the value on the number line. It's just -2. Now be careful because some students are, again, you're going to say, well, the y-intercept is -2. And then you will want to rejoice with your friends and family. But the y-intercept should be written as an ordered pair. So please do so. It should be in parentheses with a comma between the x and the y value. And like I was saying, the x value should always be 0. Always 0. Why is it 0? You can see right here on the number line, right? Because what's this x value right there? It's 0. So you guys notice I didn't calculate anything. I didn't need the y-intercept formula. I didn't need y equals mx plus b. I didn't need y equals a times b to the power of x. I didn't need any of that garbage. All I needed to do is look and see the graph. Okay, now this one, it's a new graph for us. We have all of the questions here, including at the bottom, it's asking for a rate of change. Now there's a reason why it's not giving us an interval. I'll talk about that later. But you guys take a minute, try this one out, and then we'll go over it. Let's get started then. So this line, is it linear or exponential? We'll just work our way down through these questions. Linear or exponential? I see a straight line, and since it's a straight line, this one would be linear. All right, so there's our first question. The second question, is the graph positive or negative? So this one, it's showing, at least what we can see, this is all directly above the x-axis, right? And where the x-axis is pretty crucial. So we'll have to keep that in mind. I found it right there. And hopefully your lines are straighter than mine. Either way, we look at this line and say it's all above the x-axis. But the problem is if we were to extend this line, it would actually cross over the x-axis. So I'm going to extend this one, and then I'll even extend the x-axis to show that line will eventually cross over it. Now the reason why I'm showing that is because it's not positive. It is also not negative. This one, since it will eventually cross the x-axis, this one's both. Is the graph increasing or decreasing? Good question. And remember, if it's increasing, it will go up from left to right. If it's decreasing, it goes down from left to right. Once again, I kind of look at it as like being at the bottom of the hill, and then I've got to go up the hill. I've got to climb the hill. So as a slope, that would make it positive. Since it's a positive slope or going up from left to right, this one is increasing. The next question, what is the equation of the asymptote? Well, this is a straight line, and since it's a straight line, it should not have an asymptote. The only lines that should have asymptotes are the exponential ones. So the moment that we saw that this one was linear up here was the moment that we could have said there just isn't one. There isn't a asymptote on this one. So I'm just going to put on here that there's none. On the assignment, it should tell you what to put if there is none. The next question, what is the x value of the x-intercept? Well, I had to extend the line, so I can't actually see what that value is, but I can find it. So here's how I'm going to find it. I'm going to look at 2 points that I can find on the graph. These two right here. And the reason I'm doing that is because I can make a stair step like this one, just like we would with slope, in order to find the next values on the graph. And I can see this one. I would say that it goes up and to the right. It doesn't matter because I'm just going to make a stair step. I've actually got to go backwards in order to get to this x-intercept. So I can see that it's, again, I would have went to the right 3, and then I would have went up 2. So I can go backwards. I can go left 3. Maybe that's a little far. And then down 2. There we go. So that gets me pretty close. And by the way, that x value right there would have been -6. Now, the next thing I would have to do is just repeat this stair step. So I've got to go left 3, and that would get me to a value of -9. How do I know that? Because this right here was at -6, so I'd have to go -7, -8, -9, and then I would have to go down 2. So down 1. Well, maybe I should have drawn that better, but down 2. All right. Now that should have been a value of -1. Either way, the reason why I'm doing this is because I can also scale this slope. I can say I went to the left 1.5 and then down 1 on this. Now the reason I'm doing that is because I've got to get to this point right here. If I go all the way over, I won't actually reach that x-intercept. So that's what I'm going to do. I'm going to go to the left 1.5 rather, and then down 1, and that will get me to the x-intercept right there. Now this would have been -7, so that would have been an ordered pair of -7.5, and of course the y value is always 0. So the x-intercept for me, I'm going to say is -7.5. I believe there is some wiggle room on that though. Now remember, on this one, on the assignment, it will only ask for the x value of the x-intercept. I've written it as an ordered pair here, which of course you'll want to remember that the y value is 0. The y-intercept, we don't have to do all this garbage for the y-intercept. I can see the y-intercept right now, and I kind of made it one of my original points right there, even though I've covered up the 5. So the x value will always be 0, but my y value, even though I've covered up the 5, it was 5 right there. And you could just count if you needed to. 1, 2, 3, 4, 5. So my y-intercept, again, you'll need to show these ones as ordered pairs, 0, 5. Last thing we need is the rate of change as a simplified fraction. As it turns out, I've already figured it out. And I'll show in blue right here. Remember when I went up 2 and then to the right 3? That's rise over run. I went up 2, so that's my numerator, and then to the right 3, that's my denominator. Some of you may have come up with down 2 and then to the left 3. But if you do that, you're going to need to simplify it. The two negatives will still make that a positive. So they end up being the same thing. I ended up using this slope right here. Pretty much I went down 2 to the left 3 to get back to the x-intercept there. But that's my rate of change on this one. Could we have used the formula on this one? The slope formula? Sure, we could have. You got the slope formula. The two ordered pairs that I would have had would have been -3, 3. And then also, well, I would have used the y-intercept, 0, 5. But if you put this into the calculator, you're still going to get 2/3. So either way, you can use the formula. You can just look at the graph and make the stair steps. Doesn't matter Rate of change actually is just slope. Now we got all these parts. The first one is linear or exponential, positive, negative, or both, increasing or decreasing. Find the equation of the asymptote. And since this one is curved, it should have an asymptote. And then just the x value of the x-intercept, the y-intercept, which should be an ordered pair. And then we'll work on the rate of change. That was from 4.1, from -3 to 1, all right? Take a minute, try this one out, then we'll go over it. So first off is the graph linear or exponential. I see this one is curved. Since it is curved, it definitely is exponential. Next up is the graph positive, negative, or both. Now this one, it is getting really close to the x-axis right there. And again, you may not be able to see the rest of this graph, but it is going to start leveling out right there, meaning it will never actually cross this x-axis right here, which means that this line is completely above the x-axis, which then makes it positive. Okay, the next part is the graph increasing or decreasing. So like I said, I kind of like to look at myself at the top of the hill. And since it's me, I'm round and fat. But I'm going to take my sled and I'm going to go down the hill, right? So I'm going to go down the hill. Down would indicate that this one is a kind of has a negative slope, but that means it's decreasing. It's going downward as I go down the hill from, that's from left to right. So this one definitely decreasing here. Now, since this one is curved, we do expect there to be an asymptote for this one. So what is the equation for the asymptote? It should always be y equals something. Well, what is that something? Well, I can see this line as I go down. It's getting really close to this, and it's the x-axis again. And again, over here, don't expect there to be any kind of like tricky stuff where it's going to like maybe curve back down or anything like that. This one is getting really close to the x-axis. So we're going to follow this line back over here to the y-axis, and that corresponding y value there is 0. So that's the equation for the asymptote, y equals 0. Y equals 0 has no slope. And so we just got to find the y value, the y-intercept for that. Next up, what is the x value of the x-intercept? Now, if we wanted an ordered pair, the y value would be 0, but just the x-intercept for this one. But since this line will never actually cross over the x-axis, excuse me, that means that this one actually, it doesn't have a x-intercept on this one. So this one, just like the example we did before, it has no x-intercept. Next up, what is the y-intercept? So once again, on the assignment, you're going to have parentheses and then two blanks to fill in with a comma between. The x value is always 0. So right now I'm going to fill that in. I don't really have to look at the graph for that. If it's a y-intercept, the x value has to be 0. So make sure you just put in a 0 there for any y-intercept that it asks for. After that, I look at the x-axis, which is the vertical number line here, and I just see where this red line goes through it. Now, I may have covered the number there, but you could just count the lines or the boxes. I can see that that's 2 right there. This would be the ordered pair 0, 2. Okay, so over here, I'm going to put in 0, 2. Last thing we need on this problem is the interval, -3, 1. We want the rate of change for that. Now, rate of change, just like we've been talking about, not just today, but in the bell work, and also in 4.1, the rate of change is actually another way to say slope. So, for us, we can use the slope formula for these values that they've given us. So the first one that I see here, the first x there is -3. So that means I would have to find -3 on my graph. So I follow the x-axis, the x number line, the horizontal number line to -3. I just found it. So right here, where x is -3, I'm going to follow that line up until I get to the graph. And it is pretty high up, and that's okay. So let's see if I can do this fairly straight. All right, well, that's not my best line, but it's not my worst either. So I did find that point where it goes through the red line right here. Now, I know the x value is -3 in my ordered pair. That's fine. But if you need the y value, just follow that back to the y-axis, and the corresponding y value then is 16. So we get an x value that's -3, a y value that's 16. For my slope formula, I know that the x is going on the bottom and the y's are on the top. So for my ordered pair 316, -316, the -3 is on the bottom, and then the 16 is on the top. Now, that's pretty nice, and that was fun, but I need some other ordered pair. Okay, so the other ordered pair that it tells me to use is another x value that's 1 from the interval. Again, this is not an ordered pair right there. Could you have used 0, 2? Well, for a curved line, no, because it wants these specific values, the rate of change with these values. So even though you have another ordered pair that you could use, don't use it because it's not asking for that value. So for this one, it says that the x value is 1. So on the x number line, I find 1 right here. So I did find it. And I'm going to just follow that line up. It's not very far until I get to the actual line right there. There it is. That is my ordered pair. Right there. It's pretty exact as well. So I know the x value is 1, and then I can follow that line back to the y value, which is 1 as well. Okay, so x value is 1, y value is 1. The x is 1, goes on the bottom. The y value is 1, goes on the top. So I have all the values that I need, and I'm ready to put this into the calculator. So when you put this in the calculator, here's what's going to happen. It's going to give you -3.75. We do not want the decimal. Why don't we want the decimal? Because down here it says, please put this in as a simplified fraction. So what we're going to do in the calculator to change this into a fraction, you're going to push math. If you look towards the top left, it's 3 or 4 buttons down, depending on where you count the top. It's right below the alpha button in green. You're going to push math, then you can push enter, then you're going to push enter. And it will give you the fraction of -15 fourths. And that's the answer that we want right there for the rate of change, the -15 fourths. All right, I might go a little bit faster through this one, but I can see that this line is definitely curved, which means that I am looking at something that is exponential. Next, I notice that this line, here's my x-axis, and it's going through or over the x-axis. It's on both sides of the x-axis, and so this one would be both. Is the graph increasing or decreasing? Well, I would start as far to the left as I can on this graph, which is right here, and then I can see from there I would be going up, and since I am going up here, that tells me that this one is increasing. What is the equation of the asymptote? So remember, there's no trickery right here, right? I see that this one's, it's getting really flat. That's what I'm concerned about right now. It's getting really flat here at this line where y is 4, right? Because I can trace this back to that y value that's showing as 4. So the equation of the asymptote is y equals 4. What is the x value of the x-intercept? So I'm just looking for where this line goes through the x-axis, because it's the x value of an x-intercept. And the x-axis is this horizontal number line. It's right there. I can see that it's going through there at -2, 0. So it just wants the x value though, so I'm just going to put in -2. The y-intercept is where the line goes through the vertical number line, which is this one here. And I can see the number line right there. It's going through the value that is showing as 3. So that's, as an ordered pair, that would be 0, 3. And we're going to need that on the assignment. We're going to need the ordered pair on the assignment of 0, 3. Last thing we want is the rate of change from -4 to 0. So I'm going to prepare my rate of change, my slope formula, because rate of change is just another way to say slope. We're going to find the slope. And we're going to find it between these values. So the first value that I have is an x value that is -4. That's my first x value. So on my x number line, I can find -4 right here. There's -4. Then I'm going to follow that line down to the graph. Okay, so I'm going to follow this line down. Right there. It goes all the way down to the bottom. And so, of course, the x value there is -4. But what's its corresponding y value? I'll just follow this line back to the y number line, which is the vertical one. It's showing a y value that's -3. So I've got a -4. X is on the bottom. -4 is an x, so it goes on the bottom. The -13 in that ordered pair is a y value, so it goes on the top. Next up, I will find I'll use the x value that they gave us, which was, second x value was 0. So I know that the x is 0 right there at the origin. So I'm going to just follow this line up. And yeah, we did actually already find that, of course. Some of you probably knew that already. That is our y-intercept. So, see if my technology will let me do it. There we go. So that goes all the way up to 0, 3. So again, that's our ordered pair of the y-intercept. X is 0. And then the y value is 3. I'm ready to put this into the calculator. Let's see what we get. Yeah, this one's just going to come out as a regular +4 on this one. And again, that's all I need for my rate of change on that one, or the slope. I can determine if a graph is linear or exponential, positive or negative, increasing or decreasing, and where the asymptote is. But also, we should be able to find the x and y intercepts. All that stuff that I just read is just looking at the graph. Can you see it on the graph? And then the rates of change, we use a slope formula for that one.